On the 5th of July 2016, Juno successfully arrived at Jupiter and inserted itself into a polar orbit. This means Juno has spent the last year gathering data around the biggest planet in our solar system. So what has it actually seen? Was it worth all the fuss of getting this orbiter to Jupiter in the first place? Well, take a look at a few of these breathtaking pictures, and then you tell me. Of course, Juno isn't just an expensive camera and has been performing several different scientific experiments as well, and the results have completely changed the way we understand the solar system and Jupiter. So what has Juno been doing? It's in a highly perpendicular orbit which brushes over the planet at its closest approach, only 4,200 kilometers above Jupiter's atmosphere. The furthest point takes Juno out over 8.1 million kilometers. Each orbit takes 53 days to complete, and it will complete 12 orbits by the end of its mission in July 2018. At the time of making this video, Juno has completed Perigove 6, or its 6th closest approach, so we're about halfway through this mission. As Juno is in good health, it could be that its mission is extended beyond 2018. One of the reasons Juno approaches so close to the planet is to avoid Jupiter's powerful radiation belt. There is a gap where the planet ends and the radiation belt starts, and Juno exploits that. There was some concern that Juno would still get a huge dose of radiation from the parts of the radiation belt it does hit, but the radiation was actually 10 times lower than expected in these parts. Great for the health of the probe. Do you remember the previous Jupiter probe, Galileo? Galileo faced a number of setbacks due to the damage received by Jupiter's radiation, as its orbit went right through the middle of the radiation belt, so mission planners were keen to avoid a repeat of that as much as possible. Another advantage of the tiny distance from Juno to Jupiter at its closest approach is that we've been able to see Jupiter in unprecedented detail. The first images of Jupiter's poles in particular took people's breath away. Some even say that scientists would not have even recognized the planet from these images. Just no one expected what they saw. What you're looking at here are many cyclones around the South Pole. What is remarkable is that the planet looks so different from what we're used to seeing on Jupiter, namely large bands. However, the contrast of the image has been increased to see details. The natural eye would see something more like this. This image is also a mosaic of several images in order to show daytime on all sides of the planet. The North Pole isn't quite so clear as it's in winter and some parts of the pole are in constant night. Juno also has the capability to peer deep into Jupiter's atmosphere using a microwave radiometer, which was designed specifically for this spacecraft. Using it, scientists were able to see the amount of ammonia in the atmosphere. What they didn't expect to see was this band of ammonia around the equator, ammonia being orange in this image. The pillar drops down from the cloud tops over 350 kilometers, the limit of what the MWR can see. Scientists are very puzzled by this, as they expected to see an even distribution of ammonia throughout the planet. They thought the gases in the atmosphere would just mix up, or at least stick to the band pattern on the planet. But these results are far from that. This shows how variable the planet is under the top layer of clouds. Previously, scientists had predicted that Jupiter had a solid core, but using the gravity science instrument, it seems a lot hazier or fuzzier than they would have anticipated. This could imply the core is not solid, it's dissolved, or it doesn't exist at all. And it may be a while yet until we understand the truth about this point, when all the microwave, radio wave and magnetic field data have been combined to give a more complete picture. Speaking of the magnetic field, the results from this also came as a surprise to scientists. In some places the magnetic field was stronger than they expected, and in others they were weaker. These patches you see also imply the magnetic field is being generated above the core of the planet, as it's quite irregular, perhaps originating in the metallic hydrogen layer. The magnetic field, as we know, creates aurora, and Juno has an infrared aurora mapper, giving us a view of Jupiter's aurora like we've never seen before. The central band in this animation is the main aurora, and this moving point to the left is caused by the closest of Jupiter's Galilean moons, Io. The tail of the point is the remnants of Io's orbital motion. The whites and greens from this image are ions striking Jupiter's ionosphere from space, and the reds could be ions coming from the planet itself. If this is the case, this has never been observed before. Most of the data collecting takes place for only a few hours per orbit as Juno whizzes by the planet. All the instruments collect as much as possible during this time, including the camera. This remarkable video is a time-lapse of Jupiter approaching the northern hemisphere and leaving again as it looks towards the southern hemisphere. And this image is a collection of all the frames that were used in the video. As Juno approaches the planet, you can see the storms around the North Pole, and gradually the view shifts to the mid-latitudes. Zooming in on some of these shots, you can see the classic swirls and patterns we expect on Jupiter, but having a really close look, we can see these white specks. These specks are actually water or ammonia ice clouds, as can be seen by the shadows they create. They are higher in the atmosphere than the rest of the cloud layer, and although they look small, they are actually over 50 kilometers wide. Jupiter is just really big, so it looks small. Now you've noticed them once, you'll start to see them everywhere. Due to the freezing cold temperatures at this altitude where the clouds are, and because they are made of water ice, it could very well be snowing on Jupiter. Remarkably, we are still learning so much about our giant neighbour. You might have thought that because it's the closest and biggest gas giant, we would have a pretty good understanding of its mechanics. It seems with the arrival of Juno, however, we still have a lot to learn, and there's probably questions we don't know yet, let alone answers. Well, thank you so much for watching. Your support means a great deal to me. I'm sorry for the hiatus. I've been doing a lot of work for uni, but now I have the summer off and I'm looking forward to getting some videos out to you guys. If you don't want to miss them, be sure to subscribe, and if you want to see more like this, then give it a thumbs up so I know. Thanks, and I'll see you next time.